Hello everyone, welcome to another C++ template metaprogramming video, and in this episode I'm going to show you and explain you what decltype and std declval is. So first of all, decltype is a keyword that can be used to query a certain type. So for example, if you have an integer a and equal it to 1, you can ask the compiler using decltype what the type of a is. So we're just gonna type decltype and a. So this is replaced by integer. And then we give the type, or we give it a name. So let's say b, and it's gonna be equal to 5. So decltype a is gonna be replaced by an integer. So this is gonna be int, right? So nothing really special about this. And then you have std declval, which is used as follow. You can't actually call the function because it isn't, well, it is a function, but when you try to call it, then you will get a static assertion saying that you may not call this function. And why that is, I'm not gonna explain that in this video why that is, but you can't use it because, well, this function doesn't even do anything. But it is used to create an instance of integer without giving it a value in this specific case. Or actually, you would never give it a value. You're just telling the compiler, hey, I want you to create an instance for me of the type int. So if you pass a reference, then the compiler will instantiate a instance of integer reference. But it doesn't actually really instantiate anything. It is often used in combination with decltype, so these sorts of constructions. Now this is of course completely useless because this declval, you can just it's kind of obvious what the type is going to be in this case. It's going to be an integer reference because here you are creating an instance of integer reference. So yeah, this is kind of obvious, but if you want to see this code in real life, then it would something be like this, right? So you have an integer as a equals 3, and then b equals a because it has to be a reference, right? So this is actually replaced by integer reference. So I'm gonna show you some more examples why you would use a declval and not. For instance, you can also type this decltype 0, which is also an integer. And you can do this. So then it's a double. So let's say this. So it's gonna execute some sort of this piece of code, and it's gonna check what type it is. You can also add like expressions, right? So you can do this. So you ask the compiler, hey, if I were to add a double to an integer, then what is the type gonna be? Well, if you add a double with a integer, that's gonna be a double. But if you're not sure, you can just write this, or you can also write this. You can say double and int. So now you are creating an instance of double, and you're also creating an instance of int. So it doesn't really matter that these values don't have a value. These types don't have a value because, well, it doesn't really matter what the value is, because if the double is 100,000 and the integer is also 100,000, then it doesn't change the return type of the operator plus with double and int as signature. So yeah, it doesn't really matter. But this is actually not the way you want to do this because, well, we know that double has a default constructor, But if the type you are passing in decltype does not, or the instance actually, if you pass the instance in the decltype sort of function or keyword, and it doesn't have a default constructor, well, then you would get a compiler error. So you actually always want to use std declval double and std declval int. So yeah, I mean, with double, it is possible to create this sort of instance of double, but generally you want to avoid that, and actually just always avoid it, actually, because when you're using templates, you never know. There are some instances where you're not exactly sure what the type you're dealing with is. So, and that type may have a deleted default constructor. So using declval, you're not actually instantiating an object. So it also doesn't actually call the default constructor for double. So yeah, just use declval and do not instantiate the type like I showed you earlier, right? So by doing this, or this, or this, right? Just use std declval. All right, so I told you something about deleted default constructors. So I have written a struct here. It's called a. It has an attribute called value, which is set to 0 by default. It has a deleted default constructor. It has a very trivial constructor. It sets value equal to v, and it has an operator plus, which takes in a parameter which has to be the same type as, well, this, and it returns an std string, and it adds value to the right hand side value. So normally you would call that function like this: result equals a5 plus a3 or something. So this is going to result in 5 plus 3, which is 8, and it will be converted to a string. So if I print this, then obviously that's going to print 8 as a string type. So let me just show you. Right. So yeah, nothing weird going on here, nothing special. So then we have this function, all right? So instead of calling the operator plus ourselves, let's just use the function add to do that. So we're expecting an std string as a result, but it returns an std string, and it does not return another type of a. Actually, sorry, we have to pass in a5 here and a3. So we add two instances of a. The left one has a value of 5, then right one has a value of 3, which should be 8 in a string type. But when we go to the function add, we say all the t's are the same. So this, if this were type A, then this would also be type A, and this would also be type A. But our operator string does not return type A. It returns an std string. So that's an entirely different type than the struct A, right? So let me just write what the compiler is going to write. So it's going to be A, add, A, left, A, right, return, left, plus, right. But we've just seen that that cannot work, right? because a plus a returns an std string and not a. So the compiler cannot convert this to a, which makes sense, right? Because it is not it cannot convert it. It's nonsense. It's impossible to do that. So a solution would be to change this to std string, and then it would work, but this is not a very generic solution. So we actually want to ask the compiler, hey, what if we added left plus right? What would the type be? So there are two ways of doing this. I'm gonna start off with the first one, and that is using decltype and std declval, right? So let's just start, right? So we're gonna type decltype here, and well, we cannot do this as I've shown you earlier, because T has a deleted default constructor, and we are default constructing a T here. See, I'm still getting an error. So that obviously doesn't work. So what you're going to do is, as I've shown you earlier, we're going to use std declval T, and here as well. So now you're not actually instantiating a type T, but it's just, yeah, the compiler understands, oh, okay, you want this type, but you don't want to call the default constructor. Okay, I can do that. So it's gonna sort of deduce the return type based on what T plus T is, which will be std string if we call it like this. So yeah, if you would write the function as the compiler would have, then it would look something like this. So again, T gets replaced by A, and it's gonna add a left, a right. I'm just gonna leave this empty because it's not really necessary. So yeah, this is what the function is gonna look like, right? And decltype A plus A is going to be std string, so it's going to be std string right here. All right, so that's good. All right, so that's the first way of doing this. We also have quite a bit more modern approach, and I'm not sure in which C++ version that is available, but I'm guessing 14 or 11. I think 11 actually. So what we're going to do is type auto here, and well, while this is perfectly valid, you can leave it as is, like this. It's just going to deduce, the compiler is going to deduce return type itself. But so in a way there are actually three ways of doing this, but I'm not going to explain this method. I'm going to explain the trailing return type, specifying the trailing return type. And what you do is you type decltype again, and because left and right are known by the compiler at on this position in the code, we can just refer to the instances itself without using declval. So we can just say left plus right, and that's actually the same as using std declval, right? You cannot use decltype left plus right here because it doesn't know a left and right yet. The compiler does not know anything about left and right yet, right? So it only knows that here. So the variables are created at this point, so you can't refer to them yet. That's why the trailing return type was sort of invented. So if we run the program right now, you will see that everything compiles fine. And also you can just create or instantiate another add function with the integer, right? So it's going to be int result2 result2 equals at 1 and 2. So let's just copy paste this and put it right there. So we call the same function twice, but they both have a different return type. That's actually pretty cool. So let me just run the program so you can see that is the case. And as I told you, that is the case, of course. So value equals 8, which is this one. Actually, this should be result. And result 2 should be this. So just a little semantic thing there. So yeah. So result, the first one with the A instances, is going to be 8. And this one is going to be 3. So I want to show you another example real quick where you cannot use this kind of construction. So let's say we remove this and we make it a template struct. I'm going to add a template class T, and we want to know the type when we add two T's to each other, right? So you cannot write this, as I've told you earlier, value equals, I don't know, something. It must be convertible to an int, so let's just say 0. So of course, we can do this. This is, well, valid, but as I've told you earlier, if T does not have a default constructor, well, then this whole party is not going anywhere, right? So, of course, you could do something like this. Oh, whoops, let me just give you that a different name, T. And we're gonna do this, T plus T. But now you've introduced a new variable just to know the type of what T plus T is. So that would be kind of nonsense, right? So we're just gonna put that away, and we're gonna use our function that we've used earlier, and that's declval T plus declval T. So, and we can instantiate A with int, and I'm not sure, it will probably give me a warning that A is not used, but, or it doesn't. Okay, so it builds, right? So this is perfectly valid. So this is gonna result in what int plus int is. And well, if I just copy paste this and do some things backward, right? So let's just give this a name B, and then we can create an instance of B with parameter A. So A is this and B is this, but this will lead to a compiler error, and I will show you why. So we create an instance of B with template parameter A. Let me just recreate what the compiler is going to do. So B is gonna get it instantiated with A, and std_declval, is gonna be std_declval A and std_declval A. So A plus A is the type std string, right? So this whole thing is going to be replaced by std string, but you cannot assign 0 to std string. So you have to be wary when you use this. Of course, in some cases, if you know what you're doing and expecting a certain type, then you can use this construction, of course. So you can also use some sort of static assertion. So that was my video of a short explanation of the very basics of decltype and std_declval. If you have any questions, please let me know in the comments, and I'll hope to see you next time. Bye bye.